And welcome everyone to the September 2020 edition of GlobalXRTalks. I'm Saskia Groenewegen, and Sjoukje Zaal and me will be your hosts tonight, together with our colleague Alexander Meijers, who is in Alt Space VR. And we have two amazing sessions tonight, and with us is our first speaker, Rene Schulte. Rene is the Director of Global Innovation at Valorem. He's also a Microsoft MVP, and he's very active in the XR community. So I'm sure many of you know him. And he will tell us today about spatial computing with Azure Mixed Reality, Digital Twins, and HoloLens 2. Welcome, Rene. How are you doing?
I'm doing fine. Thanks for having me on the show. It's definitely great to see you both. It's been a while. So yeah, thanks for having me. I'm looking forward to give a little bit of a session, and then maybe we have some Q&A. So yeah.
That would be great. Yeah, awesome. Yeah, you just made me scan half of my family with my phone because you showed how to do that on Twitter.
oh yeah. You have a Samsung, like the one with the time of flight. Oh, yeah. Sweet. You got it. Well, probably not in the show, but you have to show me like the results of it.
I will. I tried to. Sorry, go on.
No, you go.
No. I figured that scanning yourself is really difficult, but scanning other people is easy.
Like, that will. You know, I'm lucky enough. My 12-year-old, she was like, yeah, sure, I can do it, and so like she never did it before, but you know, easy enough. But I have to say, you know, sometimes a little bit, you know, it fails sometimes when you have a certain angle and, you know, the software is not perfect. But the results, if you finish it, are pretty good. Definitely
it's pretty
useful.
good for a phone, yeah.
Useful, and you know, the final, like the point cloud processed 3D model, it's like 60,000, something like that, vertices. I mean, of course, depends on what you do, but still, I want to say it's actually usable as it is, right? So that's pretty good. I have just real quick, I have the live stream here running on my phone as well, but on YouTube. But I don't know, is it live? Are we live?
We are 30 seconds behind, so
okay.
YouTube is 30 seconds behind, so
but we can see your comments on YouTube, so if you write, we can see it, so tell us if anything is going wrong.
Gotcha.
Yes, we will handle that for you. You can
exactly.
just focus on your presentation.
Yeah, so I'm sharing my screen, I think. So
yeah, I'm adding it. There you
Let's
go.
Get started.
Okay, want to get started? Let's do it. All right, ladies and gentlemen, welcome to the Global XR September session from myself called Spatial Computing with Azure Mixed Reality, Digital Twins, and HoloLens, and AI, and all of that. And hopefully it will be some fun. We will take about like 40 minutes, something like that, maybe 45, or maybe a little bit less, depends on it. But anyway, what we're going to talk about is I will show you some use cases, like some digital twin experience we build. I will also talk about, of course, some AI components for object recognition. Then we will talk about Azure Remote Rendering, how you can render these huge 3D models with hundreds of millions of polygons on a mobile device, like a HoloLens. And as we all know, right, it's an untitled device, so it does all the computing on the device. So Azure Remote Rendering allows us to bring in these huge models. And then we will talk a good chunk of the time about one of my favorite topics, the AR cloud, the augmented reality cloud, this kind of digital content layer of our real world. And one implementation like Azure Spatial Anchors, we're going to talk about that. And yeah, so quite some stuff. We will keep it more as in like an overview. I will show you lots of use cases and examples and some of the recent stuff I did. Some of you, if you have seen a talk of mine before, you might have seen some of that before. But of course, I always have new stuff, so stick with it. Stick with the session here. We will also have some new stuff to show, which you probably have not seen yet. And yeah, should be fun. We will actually have another event, or well, it's a like a sister event. I don't know how you want to say it, but Alexander can probably talk more about it. The Global XR Bootcamp will be happening in November, and there I will give a talk about how you can develop for Azure Spatial Anchors, right? So today it's more about use cases, inspiration, overview and so on. And in November, we will actually have some code and dive a little bit deeper into the development stack, right? Yeah, my name is Rene. As you heard, I work for Lorem Reply, do a lot of research and innovation topics there, ranging a couple of things, AI, ML, HoloLens, or if you want to call it spatial computing, like all of these devices, right, that are spatially aware. And yeah, a couple of other topics. So we are not just focused on these kind of things. Of course, Lorem Reply is a Microsoft partner for many different technologies from the back end to the front end. So we're covering all of that. And yeah, one of that is, of course, HoloLens. And we have been working with that since 2015, quite early with the HoloLens 1. These days, HoloLens 2, of course, and a few other things like mobile devices, right? It's still hot stuff. You will see it with the Azure Spatial Anchor stuff, that it's mobile augmented reality is still a really, really significant market and very interesting, even in terms of features and, development stack. Yeah, I'm also a Microsoft Regional Director and MVP. These are awards that Microsoft provides to independent experts that share knowledge. So doing lots of conference speaking, all virtual these days, of course. And then, having a few open source projects I maintain and contribute to others, as well as, being very active online, actually. If you want to connect on LinkedIn, also my Twitter handle will be at the end of the slide deck. Feel free. I keep on sharing these experiences and these kind of concepts constantly there if you're interested. All right. And then I'm also an advisor for the VR and AR Association, as well as the XR Bootcamp. As you can see, here is a calendar I got from them, and it had Baby Yoda with a HoloLens. Of course, I had to say yes when they asked me if I want to do advice there. But, joke aside, of course, good folks at, GlobalXR, the GlobalXR, the XR Bootcamp, you might have seen some of the masterclass stuff they're doing. Anyway, long story short, let's finally talk about some real stuff, some use cases. And we will start with the digital twin one, right? And so if you have not heard about what a digital twin is, it's pretty much a digital copy of a real world entity. And so that could be even a company's organizational structure, right? But typically it's something like a building, a machine, a factory, something like that, right? And what you can see here on the screenshot is a jet engine, right? And so we have this real jet engine, and then we have a 3D model of that jet engine, right? And if we take all the sensor data from the real jet engine and project it on the 3D model, we basically have a digital twin, right? And the benefit of that is, instead of having to read all the sensor data on a table, right, where you get a table, sensor ID, value, and so on, if you see that more visually in the context on a 3D model, you can imagine how it would look like on the real machine or the real object, right? And that is very useful, and that provides a lot of context and business value, because you can get insights much faster. You can also, of course, apply machine learning technology to get, basically some predictions, what's going to happen in the future. A big topic also in that space is actually predictive maintenance, right? And so all of that plays a big role. And you might have heard of Gartner, right? It's this market research company, and they say digital twins will be a huge value, and they will be a transformational technology or a topic, if you will. And that's the highest benefit rating they give, like transformational. Some might say it's disruptive, but basically they see a ton of business value here. And we also see that working with our clients, right? And there's a lot of talk about digital twin and implementations of those. And here's an experience we built for Microsoft, and in fact, for their Microsoft Technology Centers, the MTCs. And you can actually try it out there if you ever get a chance. So let's play the video and I explain it to you. So basically what you can see here, the lady wearing a HoloLens, she is positioning this chemical plant, right? So this is a 3D model of a real chemical plant, and she's positioning that 3D model there. And then in a moment, you can actually see the sensors, right? So we have these bunch of sensors here. And so you can see these boxes, right? And so these are real sensors in the real chemical plant, which are now projected on top of the 3D model of it. And we can also get the sensor reading out of that. And so we can, of course, see the temperature, humidity, pressure, and so on, from all of these sensors, right? And like I mentioned, of course, that gives us the insights much better instead of having to look through ugly dashboard, right? And so this is one part of that experience. The second part is also the a digital twin of the actually sensor box, if you will. So let me skip ahead. So you saw that. And now she's actually entering a second mode in that app where you can see how to repair and learn how to repair such a sensor box, right? So the blue box you see, this is one you might find in a chemical plant as well. And so in this experience, you also have kind of a digital twin, if you will, of the sensor box, right? That's showing you training instructions and repair instructions on site at the 1-to-1 scale with the HoloLens in your real world view blended in, and all of these crazy nice benefits, right? And again, you know, the great thing, what I always say about the HoloLens, it's not just an amazing device, it's actually you're wearing a computer on your head, right? It's a Windows 10 device. And so you wear that on your head, and basically what it means is you see a display in front of you, you have the computing on board, a bunch of sensors, right? And so spatially aware and so on and so forth. And even more importantly, you'll have your hands free, right? So you can do real tasks. You don't have to use a tablet and hold it with one hand and do some stuff with real tools. But for these scenarios, it's really awesome that you have like basically hands-free computing. Alrighty, so let's switch gears and talk about another use case, which I see quite some uptake. This is with AI and deep learning models basically running directly on the device like the HoloLens. Some call it the intelligent edge, right? So basically bringing the intelligence, the artificial intelligence onto an edge device, right? Not do all the processing in the cloud, but actually processes on the device. And so what I'm going to show you in the video is a piece I did a while ago where it does object recognition of the stuff you see in front of the HoloLens. So what I did is I trained a neural network. Basically, it went the easy path and just used customvision.ai, cognitive service from Microsoft, where you also have a nice web front end where you can upload a bunch of photos, give them a label, take another set of photos, give them another label, right? And then you have a nice web UI, hit a button, train, it will train your neural network. And usually it goes quite fast. So after a few minutes, you have your trained neural network, right? And the awesome part about Custom Vision AI is you can use it online, of course, right? You get basically a REST API for your own model, which you can then feed with images, basically, and will tell you what is in that image, right? Object recognition. But the even better is actually you can export these pre-trained neural networks and different formats, like for Android, TensorFlow Lite, or for iOS, also that format. And even nicer is it also supports ONNX, ONNX, which is a binary format for these neural networks. And the great part about Windows AI is that there's an API called Windows Machine Learning, WinML. And that allows you to take these ONNX models and run them directly on a Windows device, right? So that's what I did here. Took the ONNX model of the pre-trained stuff, right? Put it on the HoloLens and then let it just run. And this is what you can see here in the video.
This might be a car wheel 3.5 meter in front of you. This might be a matchstick 1.
So, of course, it does object recognition, like I mentioned, runs on the HoloLens. So, of course, this video is recorded directly with the HoloLens, while it's actually using the camera also to feed it into the neural network, right? That's a trick. But anyway, the good thing is really that was supported with a Windows update, I think called RS4 or something, where they allow you to take the camera feed from the device and have it in a shot mode when you record. I think live streaming doesn't work at the same time when you use the camera for things like that, but you can at least record a video. So anyway, so you might wonder, why is this useful, right? I know what a power drill is, I know what a hammer is, but the good thing is actually think about, you can use this for, basically specialized training. So you can, for example, have certain specialized tools on an oil rig or whatever, and there's like a trainer is far away, and so you get to give them a HoloLens. It would recognize what kind of object it is, and then automatically pulls in these kind of instructions and self-learning kind of guidance, right? Or think about, you buy a package at IKEA, right? You don't know how to assemble it. Just look at the package, it recognizes this, and then you can see some holographic repair instructions. Here, what you can see in the screenshot is some performance measurements, if you will, how it runs on the HoloLens. So this was done with the HoloLens 1. And what I did here is with WinML, you can execute that deep learning inference, as it is called. Basically, it means you take your deep learning model, feed it in with an image, and then you get the output out of that, right? So you have two phases with these deep learning models: training. The other one, once it's trained, it's inference, right? Basically evaluation of what you see, or prediction. And so you can run these inference on with WinML on the CPU as well as on a GPU or more specialized accelerator chips later on. And the great part is actually even the HoloLens 1, they added a driver so that you can actually run it hardware accelerated on a GPU. And that's what you can see here is you have 760 milliseconds for one run on the CPU. On the GPU, it's 180 milliseconds. And that's quite a significant change, right? But I can tell you, if you run this, I have it also running on the HoloLens 2. If you run this on the HoloLens 2, it was around 40 milliseconds on the CPU. I'm just waiting for, as you know, it's ARM64, right, Qualcomm, and a GPU is not supported at the moment with WinML, at least not the last time I checked. But I'm crossing my fingers that it will be supported rather soon. And so you can run even more complex deep learning models really fast and near real time. But again, if you run it on a CPU on the HoloLens, you actually have it faster than on a GPU on the HoloLens 1. So good stuff. Let's talk about large-scale digital twins, or rather Azure remote rendering. So let's take a look at this. What you can see here in this video is directly recorded on the HoloLens 2, right? Screen recording, MRC, mixed reality capture. And this is a 3D model which has 18.7 million polygons, right? So 19 million polygons, which is, if you have used the HoloLens before, of course, way beyond what the HoloLens can render on the device, right? As you probably know, untitled device, all the computing done here. And so typically 3D models, it's hard to say. It really depends on the kind of 3D model. But let's say like 100, 200, maybe 300,000 polygons, something you can render on the HoloLens, right? Not much more. And so how does it work that you can actually render a 90 million polygon model on a device like the HoloLens? Well, this is Azure Remote Rendering in action here. And so what it does is it basically takes the input from the device, like the head rotation, head position, hand input, all of that, and takes that stuff, the input data, and streams that or sends that to one of these powerful Azure GPU virtual machines, right? And then on these Azure GPU VMs in a data center, it gets rendered remotely. And then it streams back the result as a stereo video for the left and the right eye, plus the correct depth, back to the HoloLens. And basically what you see is a video. And as you can see, it's actually really, really well done. And there's not a lot of delay actually in these kind of experiences. And they do some clever tricks here. One of them is late state reprojection. And also what you can see right now in the video is the bandwidth, right? It doesn't take a ton of bandwidth. I actually used it with my mobile phone hotspot over 4G, and it was around like 20 Mbit, but they recommend like 50 megabit per second officially, right? But let's get back to the late state reprojection. So the late state reprojection it's pretty interesting how they do it in general. So what they do is basically they are doing a post prediction. They're estimating where the device will be moving, right? Because like if you render the frame remotely, of course, there will be a little bit of a difference, right? When you get the result back, because it takes some time to send it to a data center, right? A few milliseconds at least, and getting the result back. And so you need to compensate for that because the user might move to a different position or different rotation, right? They might just look at something else. And this is where the late state reprojection comes in, which basically will warp the result video and reproject it so that it fits where the user actually moved, compared to the estimated and predicted one. A lot of clever tricks. And again, when I used it the first time, I was so impressed how well it actually works, because I'm always kind of skeptical because, you always have latency. But yeah, they do some really good and clever tricks here. Yeah, and so why can you use that? Well, when you deal with clients, they often have CAD files, computer-aided design files. Like, if they make a new product, they typically engineer that and design it and use that CAD tools. And if you ever have worked with some of these clients, when they say like, hey, we have a 3D model already available, you can just use it. It's great. And what you get is these huge 3D models with hundreds of millions of polygons, right? The tessellated output. And what it's kind of concerning because you always have to sit down and, remove some of the details, and it's very labor intensive. And with this kind of technology, with Azure Remote Rendering, we can actually take these CAD models as they are and just put them in the ARR remote rendering stack and, execute it and see it in the HoloLens without any kind of crazy reduction that is needed. Well, photogrammetry, right? So you can take these huge photogrammetry models and show them directly on the lens. And so here is one photogrammetry model of the Pincio sculptures in Rome. I got it off Sketchfab, and it's a few million polygons. And oh, if you're not familiar with photogrammetry, it's basically a technology where you can take just a normal camera and take hundreds or maybe thousands of photos of the same object, right? Just from different angles and so on. And then you run it through software like reality capture. And this, in the end, produces a 3D point cloud, and then in the end, a 3D model. And so these are very large typically. But with this technology, we can also take them as they are, don't have to do like mesh reduction and labor intensive other things. And of course, it's information loss, right? If you reduce the information. What I can also see here, and that's also why I'm excited about this stuff, is think about the vision also, right? We have these devices, right? The HoloLens, and it's nice. You can wear it for quite some time. It's not too heavy, quite improved compared to the HoloLens 1. But still, it's not something you can wear the whole day, right? And so if we can offload the heavy lifting to these cloud machines, well, and then 5G connectivity, right? Fast connectivity, low latency. We might just, end up with smart glasses in a few years that are like this size. Really, that's what we want, right? And so we can maybe offload the heavy lifting. Of course, there are other constraints when we talk about 5G and other stuff. You don't want to have like some really hot antenna next to your brain, right? And so there are some other challenges that will be solved. But this kind of remote execution, offloading the heavy lifting, is definitely encouraging what we see here with Azure Remote Rendering. And it's being used with a couple of clients I already saw that are really loving it as it is right now, because you can take these crazy models, huge 3D models, and put them just as they are and see it on the lens. And we can even have the predator of all times. This is SARS-CoV-2 coronavirus, almost down to molecule atomic level, not exactly, but still, it's a scientific visualization. You can see these spike proteins and stuff. And yeah, it's pretty nice and detailed. It's a few million polygons, I think, this 3D model. And so think about all these scientific visualizations, right, where you have these huge molecule structures and so on, and you can just visualize them and interact with it, which is really the awesome part. It's not just static, right? And if you see this kind of, sometimes in the video, it's a little bit lagging and jittering. That's just because of the MRC, the video recording of the HoloLens. If you try it out yourself with a HoloLens and see it in stereo 3D, it's of course much, much better. You don't see the jittering, you don't see the lagging. It's really spot on and low latency. Good. Let's switch gears for the last half here of the session and talk about the AR cloud. But actually, maybe it's not switching gears, because it's also an Azure Mixed Reality service, which we're going to focus on. And of course, they all play together, right? It all comes together somehow. So what is the AR cloud? I will tell you that in a moment, but let me give you the motivation where I should care about it. Again, our friends at Gartner, they predict that this is also a transformational technology, the AR cloud. They have it on the emerging tech hype cycle, and basically say this will have a huge impact and will change how we interact with the world around us using spatial computing devices, right? And they say, well, it's going to be huge, right? And we're talking about a lot of devices that are capable of doing it, right? So we have over 1 billion devices. I think it's 1.5 billion or something like that of augmented reality devices. And what I mean is not just the awesome devices like the HoloLens. Of course, there's not 1.5 million of these out in the world, but mobile phones, like these kind of mobile phones, they have amazing cameras. And even more importantly, they have a lot of computing power and amazing progress with AI computer vision, right? So you can analyze the camera data, and they can provide augmented reality capabilities like, surface tracking, plane finding, that kind of stuff. And you have AR Core on Android, and on iOS, it's ARKit. And again, it's like 1.5, at least more than 1 billion devices out there that support these advanced AR capabilities, right? And so what is the AR cloud in the end? Well, it's a digital content layer of our physical world, right? It's basically a digital twin or digital copy of our physical world around us. And you can see it here in the video. Basically, you have these devices, like I mentioned, right? The HoloLens with all these amazing sensor capabilities and these mobile phones with computer vision, and they can reconstruct the world around us. Like you can see here in the office, they can reconstruct that office space and get basically a 3D capturing, a 3D reconstruction. And what you end up with is, in the end, if you combine it from all these single devices, these isolated devices, bring them together, you get a digital content layer of the whole world and basically a machine-readable computer vision map. And you can do things like this, right? You can position virtual panels at real-world locations. You can bring in virtual objects at real-world locations, share them with other people, and persist them there, leave them there, and someone else can come at a later time and see them in action, right? A lot of companies are working in that space. Of course, the big players, you have Google Cloud Anchors, you have ARKit introduced for iOS, ARKit 4 introduced location anchors. Then, of course, Microsoft with Azure Spatial Anchors. Then you have a few startups. Visualix from Berlin is doing well. Then you have Scape that was acquired by Facebook. You have 60AI, which is this video actually about what I'm going to show you that explains it also really well. 60AI was acquired by Niantic, the maker of Pokemon Go. And so there's a lot of movement in the AR cloud tech space. Azure Spatial Anchors, I have to say, you might say I'm biased, but I'm actually not. I'm looking at it, for the whole industry. And Azure Spatial Anchors is still the only one on the market that supports persistence, true persistence, and cross-platform capabilities for Android, iOS, and HoloLens 1 and 2. Google Cloud Anchors are just really for sharing. They work on iOS and Android, but they will be deleted after 24 hours. So you leave you get rid of the reference basically after 24 hours, which is not that great if you want to persist it. ARKit location anchors just work in some specific locations, so you cannot just use it anywhere you want. I think they start the beta in New York and London, I think, but I'm not 100% sure about it. But anyway, they all have some kind of constraints, and really ASA, Azure Spatial Anchors, is the only one that gives you the full flexibility what we want. All right, here's another quick explanation. Again, this video from 60AI, they explain it quite well here. So here you can see these gentlemen walking around that office space, right? And each of them is using just a mobile phone to capture a little bit of a 3D space in that office. So each of them is generating a little puzzle piece of the puzzle. And in the end, if you bring them all together with the AR Cloud, you have the whole puzzle, right? In this case, the kind of lab, the office space there. But if you scale it out to the whole world, of course, if you take it all from these single devices and you get your whole digital copy of the physical world, right? And this machine readable map that can be read not with GPS or anything, but with computer vision, right? And so what you can then do with this machine readable map, you can place these kind of anchors. You can place these so-called spatial anchors in the real world, which are kind of the reference locations. Anchors, just like a ship anchor almost with a ship, right? But here it's about virtual content. So you can anchor virtual content in the real world, basically, with these anchors, right? And here are some experiments. Probably some of you have seen that before, but for the sake of everyone here, basically what you can see here is Android running Azure Spatial Anchors, created an anchor there, uploaded to the Azure Spatial Anchor service in the cloud. And this now is the first person recording from the HoloLens. So I basically took the anchor I created on my Android, uploaded it in the cloud, and the HoloLens downloaded that, and it matched it into the space of the HoloLens, because the HoloLens has a little bit different spatial understanding, spatial map of the environment around it than a mobile phone has, right? And that's really the magic here, that although it's kind of heterogeneous data, it becomes homogeneous, and you can share these kind of anchors. You can have these cross-platform experiences. And again, this is not using GPS, Wi-Fi fingerprinting, Bluetooth beacons. This is just using computer vision. Well, right? But it's using computer vision and SLAM and other algorithms in that category, structure for motion, that kind of stuff. And we get centimeter range precision. Depends on the location, but much, much more precise than GPS would give you. So cross-platform, you can share it across devices and over time. You can share it over time. You can persist these anchors, right? And so here in the sample, you see when I create such an anchor at the Seattle Pike Place market pick, and then a few days later, I came back and so-called relocalize the anchor, right? So I'm basically finding if it's the same spot, it will load the anchor into the place and, matches it in there. And so you can see the same content I left there before, right? And you can see really it was a different day because the floor pattern changed. It was raining when I created, and then it would dried up when I relocalized the anchor, which is pretty cool because that's a big challenge for computer vision, right? It's a lot of contrast change, there's a lot of pattern that changed, and it still is able to relocalize and find the anchor. Pretty impressive, actually. And again, no GPS in this case used, or really computer vision. And so a lot of camera data, you might say, and you might actually say, I don't know. I don't want all this camera data on the cloud, right? Well, me neither, right? And that's actually not the case with ASA. So let's step back for a moment. Let me explain how it works and then what actually happens with the camera data. And so what you can see here in this GIF is basically these wide rectangles with the red dots around them. These are the camera frames. So this is how the device moves through the scene, right? So if it's a HoloLens, it moves like this, or mobile phone, whatever. And then these anchor data is actually extracting the relevant information from these camera frames, but it does all of that on the device. So none of these camera frames are leaving your device. So all of the pre-processing happens on device, and it extracts the relevant information from these camera frames, which are these green dots you can see here. And these are so-called feature points or feature descriptors. And these feature descriptors, a set of that makes up an anchor data, basically, right? And that defines your unique location ID, if you will. And so that's being uploaded to the cloud, right? Only this set of spatial anchor feature descriptors, only that is uploaded. Privacy, very important, right? I don't want that they upload the camera frames, not at all. And also, of course, bandwidth, right? So bandwidth is also a constraint. If you would upload all these camera frames, it would get ugly quite quickly. Yeah, so we have all of these data that is being processed, and I know Microsoft is paying a ton of attention to privacy and security in that space as well. Just last week or the week before, there was a conference called ECCV, the Eurovision Song Contest. Not at all. No, the European Computer Vision Conference, ECCV. And so Microsoft had a bunch of papers there, and one of them was also about privacy preserving structure through motion. And so they actually developed a really clever technique where you cannot even use these feature points as they are, this sparse point cloud. It's not even usable. They are actually obfuscating it even further. So long story short, I know the team also quite well. So Microsoft's paying a ton of attention to security and privacy. And I know it firsthand. And so, that's just what you have to consider if you think about all the other vendors that are emerging with AR cloud tech, right? For other companies, they're selling user data on the end, for advertisement. And so I don't know what they're doing, but definitely Microsoft is selling products and services, right? And, thinking also big time about privacy. Anyway, a few more use cases. Collaborative design review. Look at the kids and the lady. They have a HoloLens, diverse set of devices. They can see the same content, like what I mentioned before, right? This kind of cross-platform. And so here's an app which we developed, and hopefully we're going to open source it soon, where you can actually use different devices. And so what you can see here is a screen recording on an Android device. And so the gentleman is scanning around a little bit to get enough feature points, to get enough feature descriptors of the environment so that he can create an anchor. So here's the anchor visual. And the lady, if you can see her, she's moving an iPhone, right? So with Android and iPhone in this session, and she's also moving it, scanning, and basically relocalizing the anchor the gentleman on Android created. So now they're both sharing the same anchor, the same reference location, right? And we also integrated OneDrive, so can just load a 3D model, and we can share it together and interact with it. The interaction, the real-time interaction, is not part of the ASA SDK. We have developed that ourselves. You could use different technologies. We're actually using Signal on Azure, works really well. And so yeah, so now you can position these kind of objects in the real world, which you could do with AR before. But the awesome part is we can do it cross-platform, different devices at the same time, at the one-to-one scale, and we can persist it. So I could even save it there, right? And do these kind of things like, design reviews or whatever. Or, I was at some chemical companies when they install new machines at their kind of facilities. It's always a challenge because there's so much stuff. It's so dense, right? And so figuring out if that would fit in at the one-to-one scale is a huge benefit. And then persisting that and telling your colleague, hey, just go to the site. I left an anchor there with the 3D model. You can check it out whenever you have time, right? It's a huge value. And 3D capture visualization, right? So take a look at this. So here I actually persisted the sessions. I saved the session, spatial anchor session, and now loading that session, right? Relocalizing it. And it will find the anchor rather quickly. You can see it found it and now attaches this 3D model to it, which is this kind of wooden Easter bunny. And the real one is on the right-hand side, and this here on the left-hand side is the 3D scan of it, the 3D capturing. And so you might ask, how did I do that? Well, Saskia was saying it in the beginning. We both actually have the same device. This is a Samsung S20 Plus 5G, which more importantly has a depth camera, a time of flight sensor right here, right? And this allows me to do these 3D scans and really quickly, like takes maybe a minute or so, or half a minute. You just walk around it, whoop, you get a 3D model out of that. And what kind of quality it is, right? So just with a mobile phone, it's kind of ridiculous. Like, you know, in the past, we had to use really more complex settings and a depth sensor like in Kinect and so on. But these days, you can do it with mobile phones. And we see more and more of that coming with the iPad Pro. And apparently, the new iPhone will also have a back-facing time of flight depth sensor with a Sony sensor, I think. But anyway, it doesn't matter. But really, we see more and more of these depth sensors emerging. You know, a few more 3D models I did. So you can even do like facial and head scanning with this device. And yeah, all done on a mobile phone, which is kind of a ridiculous quality, actually. And AI computer vision, folks. That's really, we're at this really at the tipping point where we can have these kind of crazy things where, you know, this is just like, this is ridiculous, really. I mean, look at it. It is a single photo. And this is a new AI model that was shown at another conference called CVPR, the Computer Vision Conference. And they released a paper and even a Google Colab board, so you can try it out yourself. Just takes a single photo and predicts a 3D model. And look at it. It's pretty good. It's missing just one important thing, right? Like this. But it didn't see me on the photo from the back, right? But look at it. I mean, it's really incredible. And so a lot of progress happening in that space, right? When it comes to 3D scanning. And, you know, then you can do kind of weird things like this, where you can put yourself in your garden as a huge, you know, kind of 3D model and do some fun stuff with that. But of course, you understand there's real use cases, of course, real business value use cases. Real-time IoT digital twin data on actual equipment. Well, you can see it on the photo here. So we have these kind of machines these days which have all of these sensors, right? We talked about it with the digital twins. And so all of these sensors, when you're on site, most of these sensors are headless. They don't have a display. You don't see anything. And so having kind of a real-time data on top of that, just with a virtual dashboard that you then position and ping at the real-world location using ASA is just fantastic use case, right? And of course, the whole world becomes our canvas, right? We can draw whatever anywhere and persist it there, which is great. And so I could improve this awesome graffiti with the ugly public parking sign with our good old friend Clippy, right? And we can have Clippy in 3D. And I hope I'm not showing my age here, and a few of you still know Clippy, but basically it was a virtual assistant that Microsoft had in the 90s or something. And but joke aside, I mean, think about it. All these social media apps, you know, Facebook, Instagram, TikTok, Snapchat, all of them have a ton of investment in these AR effects, in these face filters as well. And then also they typically have these kind of AR effects. For example, Snapchat, Bitmoji, you can make these kind of funny avatars and you can actually put them in augmented reality and, you know, see this little avatar in the real world. But you can only take a photo or record a video and share that with your friends, right? How awesome would it be if I could combine it with AR Cloud and, you know, can actually put that 3D model or whatever it is in the real world and persist it, right? And share that with my friends and tell them, hey, go to this spot. I left this and that there, and you can just find it there. And guess what? Actually, Snapchat is working on exactly that. They're working on their own augmented reality cloud implementation, which they have just shown a few weeks ago at their partner summit. And they call it local lenses. And it will be part of the creator tools of Snapchat. They have this really nice creator tools and UI where you can, you know, create these effects yourself. And look at this. I mean, that's what they're aiming. And it's what I've been talking, it's like maybe since 1.5 years or something like that. Like your whole world becomes a canvas and you can paint, you can share it cross-platform and probably persisted there. I have not heard much more details since the event, how it will work and what kind of tech they're using under the hood, but definitely exciting to see all the big social media apps jumping on that as well, of course, right? All right, and let me show you something I'm pretty excited about, what I've been experimenting with the last couple of weeks here, using basically Azure Spatial Anchors, or my anchor in the real world, to put kind of time machine portals into the old times, right? And so what you can see here is a video that I got from the university library here, where I digitized some of old content. So this is a video from 1946. And I live here in Dresden, in Germany, which has some interesting history. And so we can actually, I can have put these kind of videos, these time machine portals or historic portals into the old times in the real world location where it is at the moment. And so I can look into the past kind of, right? And so what you can see here, for example, you can see these church towers there in the back, for example. This was not reconstructed after the city was bombed in World War II, right? And so I can experience how it was back then, pretty much, and see how it was looking. And so, yep. And if you take a look at this one, this is actually pretty cool. And so I got some help from Eddie who helped me to put some AI models at play here and use some pretty interesting deep learning models like Dane and Deoldify and a few others to enhance that footage with AI deep learning models. And so what it did is it increased the frame rate from 15 to 60 frames per second, 4K resolution with AI upscaled, and then, of course, the colorization with the Deoldify, right? And it's kind of incredible if you see it yourself on site. This was recorded on Android, but I could also take on my HoloLens and just walk there. It would just be the awkward guy, that's standing in the middle of a square with a HoloLens on. But anyway, the awesome part is it really feels almost like you're there in 1936, especially with the colorization. It's kind of incredible. Pretty simple to build, actually. Not that hard, right? And now I could take this, put these like 3D models or this video or graphics, images in the real world location, persist it, and then build an app and share it, and have some pretty cool touristic attractions. Here's another quick example where I didn't match it perfectly, but you can still see it okayish, I think, where I took a photo of a dam. Like that's one of the dams I visit sometimes with my bike. I do quite a bit of cycling. And so, overlaid an old photo like from 1.5 years ago as it is on top of the current situation. And as you can see, there was much more water in there. And now it's much, much less. And so I can even, visualize these not like super like back in times historic things, but even recent things like environmental changes and all of that other stuff, right? So pretty bullish about it because I think it has potential, especially that you don't need any markers, you don't need GPS. You can position them with the real world being your marker, if you will, right? With Azure Spatial Anchors. Okay, last thing, wayfinding, because you can also combine these anchors, connect them, if you will, in a session, and then basically enable wayfinding scenarios, right? So I could create an anchor here, one there, and then, connect them basically and have wayfinding. So what is shown here in this scenario is basically a factory. Think about there's a machine failing in a factory, right? And so there's a lady or a gentleman in the control room, and they have to figure out what's happening. And they might see a blinking LED on a panel. That's pretty much it. And then typically these days they have to like take a lot of paper, look through the paper, instructions, blueprint, whatnot. Now think about if we would enable them with this modern technology. They could use their smartphone, put on a HoloLens, whatever. It would recognize with AI object recognition what machine is failing. Then it would automatically load the wayfinding information, like these multiple anchors, and then show an AR, augmented reality overlay with like green arrows on the floor, guiding them to the machine. And then on the machine, we can even show them the repair instructions, right? Overlaid as holograms on top of it. And that is pretty amazing from a technology standpoint, but also from a business value, because if these machines in certain facilities shut down for a few seconds or minutes, it costs 100,000 euros, right? And if we can just, save a few seconds there, that can mean a lot and can provide quite some value. All right, so we just talked about visual content on top of these anchors, right? But there's more. We can actually not just have visual content, but also audio content, like spatial sound, right? And so spatial sound is basically allowing you, if you're wearing stereo headsets, to hear where sound is coming from, right? It's kind of a pretty cool process. And so it will allow you to sense, virtually where sound is coming from. Your brain can process that. And so that's what Microsoft applied as part of their AI for Good initiative in an application called Seeing AI. And you can see it in action here, where they're basically using Azure Spatial Anchors under the hood.
Navigate to my next meeting.
Your next meeting is with Juliet in Studio C. Would you like me to guide you?
Yes,
Are you starting from the lobby of Studio C?
yes.
Pan your phone to map the room. Follow the audio breadcrumbs to conference room 1200.
So the lady can now hear these sounds, right? These spatial anchors attached with spatial sound on top of it, and can use that as audio breadcrumbs.
Where can I sit?
Pan your phone to map the room. Table at 12 o'clock, empty seat located at 11 o'clock.
Hey, glad you're here. Let's get started.
I'm excited about that. It's really awesome that we can use this modern technology to create inclusive and diverse environments, right? Where we can solve challenges we have been facing for decades, right? And yeah, that's exciting, super exciting. How can you develop for Azure Spatial Anchors? As I mentioned, free platforms, HoloLens, iOS, Android. You can use native stack like C++, Objective-C, or Java, or C++ again, or Swift on iOS, of course. You can also use Xamarin on iOS and Android, or like probably most of us are using Unity. And so that's what we're using basically, because it also provides you the cross-platform tooling, right, for the 3D graphics stack that you will probably end up with using as well. We will dive more in the Global XR Bootcamp in November into the development stack. We will have a demo there and so on. So yeah, that's pretty much it, what I wanted to show you today. I hope it gave you some thoughts and stuff to think about, and maybe inspired you even. I don't know. But anyway, you can also see my contact info, my name, my Twitter handle. So feel free to connect, reach out. Like I mentioned, I'm always sharing that kind of stuff online as well. And yeah, I mean, exciting time to be alive, right? We see science fiction technology becoming a reality with all of these spatial computing devices, And again, it's not just the HoloLens, it's even mobile phones, right? Spatially aware. And now also with the AR cloud, we have this kind of reference, computer vision, machine readable map of the real world. And so that is exciting. And so the 2020s will not just be about COVID-19 and all that crap, but it will also be about spatial computing really taking off. And yeah, thanks for your attention. Take care, my friends, and be safe.
Wow, thank you, Rene. Really impressive stuff. Really great.
Thank you.
You also blog posts that describes these demos, right or not?
What was that? I didn't understand.
There's a bit of an echo. You also have a couple of blog posts about these demos, right?
I have some of those blog posts, but most of it I share just on LinkedIn and Twitter these days. It's just like small, snippets, and it's just easier. You can attach a video and stuff like that. But yeah, that's where I constantly keep on sharing those. I make them and then I put them online. It's like,
Okay, so we should all follow you on LinkedIn, and then we will
Maybe.
be up to date with all these cool technologies.
Maybe, yeah, if you want.
Yeah.
Good stuff.
I have one question though. You were mentioning smart glasses.
Yeah.
Is there any release date already for those devices, and a price range?
I mean, it depends. You have different companies. You know, we have the like kind of the state of the art tech with the HoloLens 2, and as you know, it's $3,500, quite expensive. Has all these capabilities. You can do amazing stuff with it. But then you have other companies approaching the market. Nreal is one example, which has these like much smaller form factor glasses. Right? It doesn't do all the processing. It doesn't have these sophisticated laser MEMS displays and all and waveguides and so on. The Nreal uses this kind of, what is it called, bird bath, yeah, where they basically have a little display like here, and then just have like a mirror, like a semi-transparent mirror in front of you where you can then see the content. And that's what they're using with the Nreal. But I tried it out a while ago, and it was impressed how well the display actually looks. It's such a simple concept. And much smaller form factor, like I mentioned. You have a little device you can use, or your Android phone actually, for the computing. And long story short, we will see much more of that approaching the market really soon. There are a bunch of other companies working on that. Of course, everyone is interested. What will Apple be doing? I think they have an event in a week or so, and everyone is expecting something augmented reality. We'll see if that happens. But yeah, I mean, once they enter the market, they will, of course, have a big impact on everyone. And so, yeah, I'm optimistic that the next few years will keep us busy in our space.
Yeah, that would be great. We're waiting for it for a long time now. So let's get started.
Yeah, that's true. Yeah, it's always a challenge. But yeah, it will pay off.
Hey, while we're waiting for maybe some more questions from the audience, I have a question about spatial anchors. So I'm a huge fan of spatial anchors. But one limitation I've noticed when working with them is because they're vision-based, is changes in light, right?
Yep.
So if you make an anchor in the morning, especially outside, you won't find it when the sun comes out, for example, if the lighting changes.
Yep.
Do you know, like, is Microsoft working on improving that? Like, is there any work being done in that direction?
I don't know for this specific thing, but I know that they're working and have a big research group in Zurich at ETH Zurich. They actually have a lab there, the Microsoft Mixed Reality Lab, which is led by Professor Mark Polyface, who is one of the inventors of these PTEM and SFM and these kind of underlying algorithms, right? And like I mentioned, they released a ton of stuff at these computer vision conferences from his group. And so they're putting a ton of research into improving it. And I know they're working on many different things. And one of those is, of course, you want to have a greater variance, right? You want to be able to support different lighting conditions. One thing that might also help, which a lot of people actually don't know, is that think about, you create such an anchor, right? And then when you relocalize it, it will also actually enhance and update the anchor data. So every time you relocalize it, it gets better and better. And the next time it will get easier to be relocalized because you have it maybe from different angles this time relocalized, right? And so that data is actually being updated. And I did similar tests like you mentioned. And in my experience, it actually worked fine. But what I did is in between, I relocalized it a few more times maybe. And yeah, it also depends, of course, on the setting and on the environment. If you have, of course, like a plain wide room kind of thing, it's, of course, as you know, not going to work. But sometimes it's, of course, a little bit experimentation. I would love, and I gave that feedback to the ATM, different feedback items, of course, but one of them is also I want to get more feedback. I want to get more visual feedback as well. Like what I want to see the feature points that it's capturing and all of that so that I can improve it, right? So that I know, okay, it's kind of, putting the anchor data, it's kind of putting this stuff in the anchor data. And I might not want to have this part in the anchor data because I know it will change. And so I want to have a little bit more insights and also a little bit more control over it. And I hope they're working on that.
Yeah. Cool. Thank you. Thank you very much for this super interesting talk also.
Sure. Yeah. Glad it turned out well.